So we're doing past paper practice. Today we're going to be starting paper 22 from winter 2017, and we will see what we get to with each question. Before we get started on the question, as we're starting a new paper, you see this big thing here at the front where it says, read these instructions first. It's not a joke, okay? It's really important. You should be familiar with these instructions before you even go in. But whenever you get a paper, you should take the time to read the instructions. So center number, candidate number, or a name on everything you hand in. They even give you space for it all at the top here. Write in a dark blue or black pen. It's quite important because sometimes those funny pale blue pens, they don't scan properly when they send your paper to be marked. And you really want to be sure that the examiner can actually read what you've written. So make sure if you do use blue, it is dark blue. Preferably go for black. HB pencil for any diagrams or graphs. Again, it needs to be a dark enough pencil that it scans nicely. Okay, no staples, paper clips, glue, or correction fluid. And do not write in any barcodes. So this job is here. Don't write anything in them because that, of course, is how they identify your paper. Paper 2, paper 4, both the same instruction. Answer all the questions. If working is needed for any question, it must be shown below that question. So you'll see as we get into the questions that there's space given for your working. And then we work in that space only. Okay? Electronic calculators should be used. Both of your papers at IG are calculator papers. Okay, this is a big one. If the degree of accuracy is not specified in the question, and if the answer is not exact, give the answer to 3 significant figures. Give answers in degrees to 1 decimal place. Don't throw away marks just because you don't round properly. So always keep that one in mind. Okay? For pi, you're using either your calculator value or 3.142. Then you have a little bit more admin. At the end, fasten all your work securely together. Okay, so if you have had to use extra sheets, your exam venue will tell you exactly what to do with them. The number of marks is given in the brackets at the end of each question or part question, and the total marks for this paper is 70. So you've got 1 hour and 30 minutes to do 70 marks worth. We have a question here about the candidate number. So your candidate number and your center number, you'll get both of those from your exam venue. Because when they send your entry through to Cambridge, that's when Cambridge sends back what your candidate number is. So that will be all on all your official paperwork that you get from your exam center. No need to worry about it at this stage. So here we go. The first question, what are we dealing with? One day at noon in Maseru, the temperature was 17 degrees C. At midnight, the temperature was 20 degrees C lower. Work out the temperature at midnight. So they're giving us a nice, gentle introduction to this paper. Okay, so at noon, the temperature is 17. At midnight, 20 degrees lower. So we would have 17 minus 20. So we're working with our directed numbers here. Difference between 17 and 20 is 3. Larger number is negative, minus 3. So however you want to do it. The answer is minus 3. And you see there, they put the units for us. So nice and handy, but keep an eye out because sometimes they don't. So next one. Another straightforward, 1 mark, let's get you in gently kind of question. Write 5.17 times 10 to the minus 3 as an ordinary number. Now remember, if we have 10 to the minus something, it's going to be a little number. If we had 10 to the positive something, it would be a big number. Okay? So, there's a little note. So what we're looking here is a very little number. So 0 point something, 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 and then there's a 5, 1, 7. So 10 to the minus 3 means we will have bumped that 3 places. So 1, 2, 3. So we're going to need 2 zeros in here, and we can check it again. 1 bump, 2 bumps, 3 bumps would have 5.17 times 10 to the minus 3. So even though we've worked here, we always give that final answer on the line as well. So 0.00517 is our ordinary number. Now we get something different. So these past paper sessions that we're going to do are really going to bounce around between different topics. So it's fantastic if you're just starting, it's fantastic if you're in the middle, it's fantastic if you're at the end. It's a good lot of revision and extension for everybody. So what have we got here? We've got a triangle ABC, we've got a line LB and a line MN. Okay, they tell us in the diagram, BL is the bisector of ABC, angle ABC, sorry, and MN is the perpendicular bisector of AB. So remember, if you were going to do these, you would have used your compass and put your arcs, and you would be able to do these bisectors. Okay, but in this case, they've done it for you. So complete the statement. The shaded region contains the points inside triangle ABC that are nearer to B than A, nearer to B than A. So for that, nearer to one point than another, of course, we would have our perpendicular bisector and we would look to the right of it to be nearer to B. So now, they are also nearer to what than to what. So we've dealt with the perpendicular bisector. That was our first point. So the second one is all about the bisector of the angle. And remember, we use an angle bisector when we want to do equidistant from two lines. So here we have equidistant from two lines, whereas a perpendicular bisector, that's all about equidistant from 2 points. Big difference there, okay? So when we're working with this perpendicular, the bisector of angle ABC, we are working with which lines? Okay, so if we're bisecting the angle, we're working with the line BC and the line AB. So our shaded area is on the BC side. So we are nearer to BC than we are to AB. So we're equidistant from 2 points, but we are then shaded closer to B. We are equidistant from 2 lines, and then we are shaded closer to BC, 1 line. Okay, always remember that if you're describing a point, you use 1 letter. If you're describing a line, you must use 2 letters. So our shaded region is nearer to B than to A, and nearer to BC than to AB. Next question. Question 4. 1 and 12 are factors of 12. Write down all the other factors of 12. So they've done the 1 for us. 2 times 6 gives us 12. 3 times 4 gives us 12, and we've wrapped around. So the factors of 12 are 1, 2, 3, 4, 6, and 12. They also like to test our multiples. Okay, remember, factors are little number, multiples are bigger numbers. Okay, so write down the multiples of 9 between 20 and 40. So not 2 times 9, but 3 times 9 is 27, and 4 times 9 is 36. And if we went to 5 times 9, we'd be at 45. We're outside where they told us to stick to, that 20 to 40. So our 2 numbers, 27 and 36, are our multiples of 9. Question 5. So we've gone from the very beginning of the course now to quite far in, talking about angles. So we have here a triangle, we have an extension, we have angles inside the triangle, we have an exterior angle as well. Okay, so in the diagram, AB is a straight line. Brilliant. Okay, find the value of X and the value of Y. So how are we going to do this? We need to think about what we know. Okay, so we know a couple of things that are useful here. We know that angles in a triangle add up to 180. So angles in a triangle add to 180. We also know, remember they told us AB is a straight line. We know that angles on a straight line equal 180, which should be good. So the value of x and the value of y, well, we can't do angles in a triangle when two of them are missing. But we can do angles on a straight line when only one of them is missing. So x is going to equal 180 minus 120. Remember also when we're doing maths that we're going to use an algebraic x, not English x, because that means multiplication in maths. So we want to rather stick to this lovely curly algebraic x. Okay, so x equals 180 minus 120, x equals 60. So here they have not given us units, see? So we have to look out and be careful. X is 60 degrees. So y equals, we now put our 60 here because we know that x is 60. And now you see in our triangle, we have two of them, we're only missing one. And if we're only missing one, then we can use our relationship. So y is going to equal, let's not do it. Ooh, whoa, hold on. We rather need to erase this and make more space so it's clear. So y is going to equal 180 minus the sum of the other two angles. So 80 plus 60. So y is going to equal 180 minus 80 plus 60 is 140. So y is going to equal 40 degrees. So then y equals 40 degrees. We've solved for both x and y using that information that we know and the information that we're given. So we're heading towards a percentage. I like grams, so let's work in grams. So 2.2 kilograms. To convert to grams, we need to times 1,000, because there's 1,000 grams in 1 kilogram. That's going to give us 2,200 grams. So we've got 2,200 grams. 55 grams as a percentage of 2,200 would be 55 divided by 2,200 as a percentage. So that's our fraction times 100 gives us our percentage. So we can either do this in our heads or we could put this on a calculator. And what we get is 2.5%. So our answer, they've got the percentage for us. We just put the 2.5. 55 grams is only 2.5% of 2.2 kilos, which kind of makes sense because 55 grams is a lot smaller than 2.2 kilograms. So you always want to have that in mind. No? Does my answer make sense as I'm working through this? If we got an answer that they said like 200%, we're like, no, something's going wrong. Okay, so always thinking of the question and what my answer should be as you work through. Question 7. What have we got? The area of a triangle is 528 centimeters squared. The length of its base is 33 centimeters. Calculate the perpendicular height. Now with something like this, I really like to actually draw a sketch because it helps me to figure out what information I've got there in the question. So if we sketch this question, there's a triangle, a random triangle, they've not told anything about it. We know the length of the base is 33 centimeters. We know the area is 528 centimeters squared. And the perpendicular height would fall here. So now we're looking at our triangle and we say, hold on, we've got something that links the area, the height, and the base. Because remember, area of a triangle equals 1/2 base times perpendicular height. So just because we have the area already doesn't mean we can't use this formula, because we can always substitute into a formula and calculate any piece of it. So area is 528 equals 1/2 times the base is 33 times, we'll leave h for height. So now we've got to solve this for the height. So how are we going to do this? Okay, well, first thing, I reckon we're going to get rid of that 2. Remember, if we want to clear a fraction when we're working in an equation, we're going to multiply through by the denominator. So we're going to multiply this whole side by 2, and if we do it to one side, we do it to the other side. So 2 times 528 gives us 1056 equals. On this side, those 2's are going to cancel, because this is all multiplication sticking everybody together. So the 2's cancel, and we're left with 33 times h, which we can also write as 33h. We don't need to put that little x in there for a multiplication. When a number is stuck to a variable, it means multiplication. So now we need to get rid of this 33 to find out what h is. So we divide through by 33 on that side, which means we do the same thing on the other side. Okay, here our 33's are kind of cancel. 33 divided by 33 is 1. So we have just one h standing alone. 1056 divided by 33, that gives us 32. So our perpendicular height is 32 centimeters they've given us. We're happy with their units. So our answer is simply 32. Perpendicular height of this triangle is 32 centimeters. And we change to another completely different topic. It's the joy of IG Maths. They throw so many different things at you that you get an enormous amount of variation within your paper. Because of course your paper 2 and your paper 4, both of them testing everything you've done. So a Mars cycles at a speed of 18 kilometers per hour. It takes him 55 minutes to cycle between 2 villages. Calculate the distance between the 2 villages. They're getting sneaky with us again. Did you spot it? He's cycling at a speed of kilometers per hour. It's taking him 55 minutes to cycle, and our answer is in kilometers. So that 55 minutes is a problem. Okay. A very friendly triangle. How everybody is related. We are looking for distance. Okay, so from this triangle, we know that distance equals speed times time. Okay, we can work with this, but we're going to have to be careful of those units. So our distance equals our speed, 18 kilometers per hour, times the time. And that's where the catch comes in, because you can't put kilometers per hour and minutes in the same calculation. But you can put kilometers per hour and hours in the same calculation. So 55 minutes would be 55 over 60 hours. We always convert from minutes to hours by dividing by 60. If you have 60 minutes, then 60 divided by 60 is 1. You've got 1 hour. So you can always do little calculations like that in your head to make sure that you've got things the right way around if you're a little bit worried. Okay, so now we've got very simply 18 times 55 divided by 60. So D is going to equal 16.5. So 16.5, who? Kilometers, because that's what we were working with in this question. We didn't have to worry about that length at all, and the units for that length. So 16.5 kilometers is the distance between the two villages, because it took him 55 minutes to cycle that far. Right, next question. Work out giving your answer in standard form. 1.2 times 10 to the 40 plus 1.2 times 10 to the 41. So we already touched on standard form a little bit earlier on when we were converting with that small number. Now here we're working with positive exponents. So these numbers are enormous. Okay, 40 and 41, they're huge. In order to add them though, we're going to have the same exponent here. So if we want to work with 1.2 times 10 to the 40, we're also going to have to convert this one to 10 to the 40. So 1.2 to 10 to the 41, if we want 10 to the 40, we've got to move that decimal point back one, because we're only going 40 over. We're not going all the 41 over. So this would then be 12 times 10 to the 40. Now you can see our 10 to the 40, all those huge amounts of zeros line up. So we can add our 1.2 and our 12. 1.2 plus 12 just gives us 13.2. But now times 10 to the 40, don't forget all those zeros. But that is not in standard form. So we need to move that decimal point over again, because we can't have two digits before our decimal point for standard form. So 1.32 times 10 to the, if we're moving that decimal point to the left, we are adding a number. So 10 to the 41. So our answer here would be 1.32 times 10 to the power 41, the addition in standard form, just as they asked us for. So the next question looks at the size of a triangle. We've got 5.2 centimeters, 6.3 centimeters, and 9.4 centimeters. Here's our trigger phrase. Each correct the nearest millimeter. We're talking bounds. Calculate the lower bound of the perimeter of the triangle. So, given that people thoroughly enjoy bounds questions, I don't want to rush this one, and we've only got a few minutes left. So we shall kick off with this question in our next paper 2 session. Is there any questions on what we've covered so far? Or is everybody happy to carry on with this paper in 2 weeks' time?